Good afternoon, welcome, and thank you for joining Databricks and AtScale today. I'm Michael Sullivan, Technology Partner Sales Director for Databricks in Europe, Middle East and Africa. As the world of data and AI evolves rapidly, the demand for open, performant and collaborative platforms has never been greater. Today we'll explore why a standard for creating, sharing and reusing semantic layers is key to bridging the divide between traditional BI and the future of what we call generative BI. Our presenters today are Dale Williamson, a field CTO at Databricks, and Dave Mariani, CTO and founder of AtScale. Prior to AtScale, Dave was VP of Engineering at Clout and at Yahoo, where he built the world's largest multi-dimensional cube for BI on Hadoop. Dave is a big data visionary and serial entrepreneur. Together, they will guide us through the following. Firstly, how the semantic layer and SML, or semantic modeling language, accelerates analytics adoption, facilitates vendor migrations, and democratizes data and analytics. We'll also cover how the combination of AtScale and Databricks can connect traditional BI with generative BI. And finally, we're going to look at some practical ways to integrate your semantic layer with Databricks. Capabilities like Unity Catalog Metrics, Lakehouse Federation, AI BI, and more. Now, if you have questions during the webinar, please ask them in the chat window, and we will answer as many as possible as we go along. This webinar is recorded, and you will have access to the content to review at a later date, provided in a follow-up email. Now, over to you, Dale, and thanks.
Awesome. So I'm really looking forward to today's webinar. So Dave and I, we did this talk, sort of recorded podcast about a month ago now. And we kind of went in a lot of different directions. But one of the primary things was talking really through around the standards for semantics. So I'm super excited to be part of this webinar today. The format's going to be slightly different. I'm going to go through sort of a point of view on the importance of semantics on the market and kind of level set where this could take us. And then Dave is going to come in and actually walk through like, what are these really cool things that AtScale's discovered and some of the things they've done around their open sourcing with their markup language. So very, very excited about how that's going to sort of play out. I want to talk a little bit about the importance of semantics and kind of firstly what it is, what it does, but also why are AI-driven companies embracing this and embracing it in the spirit of achieving interoperability. And that in itself is a really fascinating thing. So just as a layman, what is semantics? So lots of people use words interchangeably. So we often hear people talk about semantics, talking about context, talking about metadata. There is a relationship between these three things, and they are incredibly important, but the specific meaning is actually even more important. So semantics, very specifically, is examining the inherent linguistic meaning sort of behind language. Context really runs through the background to interpret the meaning. So it's more of the interpretation. And actually, if you think about kind of the direction of AI and reasoning and things like that, this is becoming incredibly important. And then metadata is more the description of data to aid in its management and use. And while related, they're each offers sort of different types of information about language and data. Now, the interesting thing is that's more kind of general terminology. Linguistic semantics and computational semantics share a similar sort of fundamental goal. But computational semantics is more about creating structured machine interpretable representations. And that's super important when you want to be able to do things like integration, analysis, automated reasoning. Now, as we move more and more into that kind of AI world, this becomes more and more important. The analogy on the side, why I've got the culture map in there, is because actually we do this every day. Like lots of us don't realize how much we do this, especially if you work in a place like EMEA, like I do. Europe is just the Europe, the E part, has many different sort of cultures, many countries, many cultures, many different ways of communicating. And each of these sort of 8 factors that Erin Mayer so expertly puts together, she's part of the INSEAD Alma Mater, she kind of deconstructs like ways in which people sort of make decisions, ways in which people communicate, ways in which people think, how they lead, how they get things done. And just to give you some like examples, you have things like leading. You have some countries in the world, like the Nordics, that are very egalitarian. They're very flat. Then you get other countries in the world, like sort of France, Spain, Italy, that are very hierarchical. You also get things like persuasion, where people use a principle first method versus other people use an application first method, and it's really fascinating. It's a great book. But what happens almost inherently as you do business more and more in places like this, or travel more and more, you start to become increasingly aware of these nuances, and you adjust your language to sort of make for that. So it's like a kind of reverse personalization. We sort of see this being a huge shift that's going to happen as a consequence of how AI is coming to the fore, but also how we're expecting things to move at a faster pace. Now, just to put this into a kind of very practical term, you have an engineering team, they will create a catalog. This is a very structured set. So you have metadata, and this metadata is very specific. And what you're missing here is the inherent meaning, but you also have a lack of that kind of context. So what's really important is, how do we sort of bridge when a CEO asks the question? And typically today, this kind of happens in a really haphazard way. And the idea is, as we start to become more question-oriented, and as we start to really think about how we build this bridge in between, we start to think about what are the building blocks that are needed, what are the missing elements, right? So as we move across, and in effect, like the bridge and the gap to kind of take that sort of higher order thing and actually answer that question in a far more inherent way. And it's a really fascinating thing, because, as Andre Karpathy talked about, LLMs becoming the new programming language, we're sort of seeing that this is an incredible way in which this tool can play a material role in changing how we work, changing how we communicate. So why should you care? Well, every company has a semantic layer. They've built it up over time, even sort of new companies, but especially the older you are as a company, the sort of more you've sort of built up over time, you have this. Why is it important? Well, by optimizing and making it far more coherent and far more accessible and far more decluttered and incredibly sort of well maintained, you create better business intelligence. And that's actually, a lot of that's going to flow through this talk. You're also going to be able to build better AI apps, because this stuff's incredible for fine-tuning data and fine-tuning models and making sure that things are far more domain specific to your environment. It also allows you to make the most of AI, because it sort of acts almost like as a safeguard and or a guardrail. So just setting this back, around about June at our summit, we made this massive announcement around Unity Catalog metrics, which, fun fact, was actually born out of our own sort of solving of metrics internally. And we called out, these different partners that play a role in this shift into a more AI BI product line, which is, how do we bridge the divide between business intelligence, which is very reporting focused, and sort of AI BI. So why is this a big problem? Why do we think that this is a huge frontier that needs to be kind of corrected? Well, if you kind of work through, a human has skills to read dashboards, and that's currently what we are allowing for at the top of this. Typically at the bottom, we take data, we create information, and we'll create sort of an analytical space for slicing and dicing and doing sort of things. Those manifest as reports or as sort of workspaces. but they're very narrow focused. And what happens above is a lot of organizational productivity loss. So there's a huge amount of waste that happens in the system. The amount of people that have to take a dashboard and copy it and then put it into a PowerPoint and annotate it with context and then push it up the management ladder to be able to explain up. And that costs a huge amount of organizational time. And we think that this is a fundamental rethink, and generative AI, semantics, and context give us a huge amount of anchorage here. So we thought about this through first principles. We started a project called Project 1B. That was, how do we make data accessible to 1 billion users? And in doing that, we learned that actually there's some very, very interesting points here. So Databricks has always done the deriving, information, so tables, knowledge, so volumes and models, and we can build insights and create these compound systems. And that effectively creates this inherent intelligence. But the context and semantics are this next frontier. And that's ultimately what we're trying to solve for, is that you have skills to kind of read through this context and semantic layer. And it's a really fascinating thing when you actually go into how do you solve for this problem. So I want to quote Bill Gurley on this, because the best technology for solving complex problems is open source. And we think that this is one of the biggest, most complicated problems that there are out there, because this effectively is that layer just beneath humans and the human interface that connects into technologies. And fun fact, it is an incredibly proprietary one. So we open sourced Unity Catalog back in June. And the idea was to create this kind of interoperability across any format, whether that be knowledge, so the unstructured data sources, the structured data sources, or different models that we can abstract using AI gateways. And if you take this thinking and play it into the kind of stack, you have the de facto storage layer like Parquet, you have a whole series of different models that are open source or sort of closed source that you can abstract away. You have a whole lot of open source code, a whole lot of open source MLOps frameworks like MLflow, and you have the uniform formats, and then you have Unity Catalog. What that leaves us with is the space above. So if we put that into the relationship between that actor and how they're assessing, and we layer in the other sort of parts, what we actually start to see is lock-in through a totally different lens. And one of the most locked-in layers of the stack is that semantic layer. It's where all the business rules sit. It's where all the process logic sits. It's where business process logic. It's where actually metrics and KPIs and all sorts of things lie. And a lot of that is baked in over time, and it hasn't actually been gone through a sort of decluttering. And one of the things we think that's going to happen is that this is going to be the next frontier for open sourcing and sort of unification. And there's a lot of very, very good reasons for it. Why is this so important? So I'm going to kind of take you a little higher and go, and then we'll bring you back down, as Dave takes you through some of the other things. So how does this unlock something that's a much higher order problem? So we've talked a lot about how sort of data collaboration can actually make an impact on businesses. And this is in all sorts of spaces. Lots of people talk about internal sharing, like data mesh and all of those things. That's really hard unless you have these sort of open standards. We talk about things like peer-to-peer sharing. We talk about things like SaaS application sharing, privacy safe collaboration. All of these different things that aspirationally will unlock companies and sort of drive insane amounts of productivity improvements and reduce a huge burden. When we deconstruct that, what we sort of want to get to is this world of multi-cloud interoperable data products, where these data products can kind of be shared and moved around. If we take that into a far narrower focus, let's presume we have three domains, and they have very fundamental differences in how they design and how they kind of play out. So this is a generalized view of an actual architecture. And I'm going a little bit deeper because details matter. I don't want this to be high level general. Details matter, and the devil is in the detail in terms of solving interoperability. But I'm going to start with how humans are kind of working. And this is an actual use case. So we have human distribution. We have 500 people, we have 2,000 people. We effectively have a head count of 2,650 people in total. And what we want to do is reallocate 2,000 of them to work on AI applications. Because fundamentally, they're all doing a very similar thing. So what we did was we thought, what if we were to create the semantically consistent layer that allows for domain to domain exchange of data products? What would that look like from a data exchange perspective, but also from a semantically consistent and contextually sort of relevant perspective? How does that work? And this is within the borders of an existing organization. It's not going organization to organization, because that actually takes us to another far higher order place. And if we think about it, people are buying different solutions and they're working with those solutions in different ways. So what if we were to kind of play in like the kinds of constructs, like we could use, a federated construct with companies that have more open source, and we might use a gateway construct where things are inherently more closed. And what would that look like in terms of a reallocation of headcount? And what we've achieved through like thinking through this thing is how important semantics are and semantic consistency is in terms of defining how domains kind of interoperably work with data and change and are able to communicate with each other and create faster flow in an organization. What I mean by faster flow is the rate of communication and data exchange increases to the point in which the cost of doing business reduces. Therefore, they're able to produce more goods, more products, more services. And it helps for the coherence of the organization to play out. It also helps for humans in the organization to focus on higher order value and massive things. So the idea here was to reallocate. Now, what could this look like if we take this even further into a kind of broad world? Like if we took a variety of different companies that are using delta sharing in this interoperable exchange, they can start to create a huge amount of innovation upstream and downstream of supply in the ecosystems that they operate within. So this tangible example looks like a planet for a reason. So this is an extremely interesting rethinking exercise. And, I've been talking quite a lot about how this could kind of manifest and sort of ideas around this. So one of the fundamentals that we've been asking is what is likely to change? So for many, many years, we've talked a lot about industry or domain-centric data models. We've talked about these very, very sort of general things. Now, the problem is they've never worked because companies are very specific. And general helps to get to a kind of baseline. But then what happens if you operate in 14 markets and the model only sort of works to 3 markets? There's sort of fine tuning that has to take place. It's not actually that different from how a general model needs to become more domain specific. So one of the things we've been thinking about is, can we figure out how to create sort of domain specific semantics within different companies? And are we starting to look at this relationship between semantic layers and models? Now, the reason I bring this up is because I want to plant the seed, because when Dave shows you the demo of some of the things that they've done using semantic models and our Genie solution, it starts to get to a level of accuracy and coherence that is quite remarkable. And that whole idea of creating human to human or team to team or business unit to business unit APIs becomes really interesting. Anyway, that's my kind of projection into the future. Let's get back down to earth and look at where's a good place to start. And this is where I tee up Dave to kind of really talk through some of the grounded things that we're doing today with @scale and how we're playing out how to unify the semantic layer and the impact that that can have, and how that drives better business intelligence, but also how that relates to creating very accurate models and very accurate sort of AI applications that play into the future sort of state of how that company wants to operate. And with that, I hand over to Dave.
Hi, everyone. I'm Dave Mariani. I'm CTO and co-founder of AtScale. So let's build upon what Dale has already set up. And let's show you how semantics work for AI and BI in Databricks. So first of all, just a definition. Semantic layer is a business-friendly layer on top of your data in your lakehouse. And what that means is that we're going to expose common terms that the business will understand, things like product, customer, revenue. And it probably sounds familiar. Yeah, semantic layers have been around forever, right? But they've really been available tightly coupled to consumption. So you have multiple semantic layers, and those semantic layers are typically embedded in each consumption tool, like Tableau, Power BI, Excel, etc. So what that means is that you end up taking data out of your beautiful lakehouse and you make it small. You make it small by loading it into proprietary cubes or caches or other sort of forms that allow these tools to work at scale. The problem is that it only takes a sliver of data because these tools can't really scale to a lakehouse size. So you have now limited view for what you can do with that data analytics wise. And it means that your semantics are now locked in with your tools. And if everybody is using sort of a different tool to define their semantics, I can guarantee you that common KPIs are going to be defined differently in those tools. So you end up not trusting the results in your analytics because gross margin in Excel doesn't match gross margin in Tableau or Power BI. So what's the alternative? The alternative is to take your Databricks Lakehouse and add a semantic layer on top of it. I'll be talking, of course, about the at-scale semantic layer. And not only are we going to allow you to have one single source of truth, we're also going to accelerate your Databricks SQL queries, so we can deliver the same speed of thought type of analytics that you get from those proprietary formats without data movement. So there is no import here. At-scale is a virtual layer. That means you can have a single place to govern those assets in your lakehouse, and you're going to get one consistent view of your KPIs and your business metrics, regardless of how you consume them. So this is all backed by a semantic model. So at-scale semantic models are based on an open source semantic modeling language called SML, stands for Semantic Modeling Language. This is semantic modeling language is YAML, and that YAML is stored in Git. So for at-scale, Git is the source of truth and is the way that you collaborate and treat and build semantic models just like you would code. You don't have to be a developer to use and create semantic models. You can be a developer and you can write SML directly in a sort of code first sort of manner, or you can use at-scale Design Center to visually build models with no code at all. In either case, you can collaborate, and both types of personas can build models together using their respective skills. Of course, it's all integrated with Unity Catalog, and it's consistent not just from a consumption perspective, it's also consistent from a model perspective, because at-scale SML is object-oriented. You can reuse and define these objects across models and be assured that there's consistency at the semantic layer. So that semantic model that you see on the left will appear in your different tools using those tools' native dialects. So you can use Power BI the way you use Power BI with Power BI Premium, which means it speaks DAX to the at-scale semantic layer. So you can create client-side metrics. You don't have to have features turned off in Power BI using things like direct query mode. You can connect Excel directly to the semantic layer. There's no dumping data. You can create your models using notebooks and the Databricks workspace by connecting to at-scale with Python or Spark. So we support multiple protocols. So how it all works at scale is all container based. You can install those containers with Kubernetes, however you like, or use our native cloud integrations. And we sit on top of your medallion architecture. We like to think of at scale as a platinum layer in your semantic lakehouse. So at scale will automatically tune queries and create aggregates on top of your lakehouse so that we can deliver speed of thought queries. Your users out here are going to be dealing with a very business-friendly interface that's going to be consistent across all modes of communication. All right, let's get into it. I'm going to start from the end, and then I'm going to work my way backwards. So let's start with the Databricks workspace. So AppScale integrates with the Databricks workspace simply through an external catalog. So if I go to my external catalogs and I look at my catalogs here, I've actually created a connection to my AppScale instance I'm going to be using for our demo today. So you can see here's that reference. Here's the reference to the Design Center, which you're going to see in a bit. And I just created a connection using our Postgres interface. Now, once I've done that connection, I can go ahead and create different catalogs that then appear within my catalog explorer right here in my Databricks workspace. So here that is, and you can see that I have there's my catalog, and then here within each of my catalog, I have a database for different business areas that I've created in my at-scale semantic layer platform. And you can see that each model, in this case, my TPCDS benchmark model, appears as a single flat table inside of Databricks. Now, here's all of my measures and my dimensions expressed, 15 pages of them, which allows me to run queries or ask questions using Genie. So if I go to Genie and go to a workspace and look at the definition of that workspace, you can see all I had to do was add the at-scale semantic model as a single table. So there's a reference. And then what I can do is I can simply ask questions of the at-scale semantic model, like what is the total quantity sold each year. Now, why'd I ask that question? It seems like it's pretty simple, right? It's like, okay, that's a really silly demo because that's as easy as it gets. Well, there's actually something that's not so obvious. Total quantity for a TPCDS model is not straightforward because the TPCDS model is based on a retailer, and the retailer has multiple sales channels. They can sell across catalog, store sales, as well as web sales. And so with the at-scale semantic layer, we made it really easy for Genie to get the right answer. You can see it went ahead and summed the total quantity sold metric, which is correct, which includes all three channels, which gets the right answer. It's not that's a very simple view of what happens here and the power of that semantic model. Okay, let's go ahead and build a semantic model and deploy it, and then go use it in not just Genie, but also Power BI and Excel. So what do you see here? This is Design Center. Quick orientation. You can see a visual view of your model, in this case, internet sales. You can also see a code view. Here's our SML. Now, as I create models visually, it actually generates the SML code. If you want to know about SML, come to the Semantic Data Layer organization in GitHub and go to the SML project, and you can see the open source project. You can also see all the examples. Here's the SML definitions, and you can see all the samples I'm using today. I showed you TPCDS, and now I'm working on internet sales. You can get those and try those for yourself, and you can even download and use at-scale for free and try it out for yourself. Okay, so let's go ahead and build a new model. Before I do that, you notice that I'm working on the Internet Sales Tutorial repository. So I'm just pointing to our open source repository, and I'm actually working on a Databricks branch. So we're just working off of a GitHub repository here. So all of the SML is stored in GitHub natively. So I don't have to. I can work in my branch and deploy and test as other developers do the same. It's collaborative from the very start. It's built into the DNA. So let's go ahead and build a new model. And I'm going to go ahead and create a new model. Let's see, we're going to call it, I love Dale, so I'm going to call it a Dale model for his benefit here. So Dale, you are now a internet sales model. Happens to be a model that is modeled on a web retailer who's a bike shop. So I just created a stub for that. Not very interesting because you can notice that I don't have any dimensions or measures yet. This is the preview. This is what people are going to see in the consuming tools, including Databricks. So let's come back and let's go and let's explore some data. This interface looks a lot like Visual Studio Code because we based it on Visual Studio Code. So I'm going to go ahead and go to our data sources panel. You can see here that this is all integrated with Unity Catalog. So these are all the catalogs I can see and directly present in AtScale. So there's the schemas, the databases, and the tables. You can see here, I'll go ahead and preview this fact internet sales table. And I can see that, and I preview this table, I can see that it's kind of messy. You can see I got dates that are strings, that I got shipping dates that are numbers. It's all over the map. Not quite a gold, but that's okay. That's not going to stop us. Let's go ahead and add that table to our model, and by doing what I just did there. So by adding that table to our model, now we got our first table here. Had to find it, and that now becomes a data set. This now becomes usable and reusable across my models. And I'm about to create some metrics here. All I need to do is take order quantity, for example, and sales amount, and I could use our bulk metric creator. So I'm going to call this orders, and I'm going to call this sales, and I'm going to put it into a folder so I can find them. I'm going to call it my metrics. Now, this is a way of creating a bunch of metrics really quickly. AtScale has chosen the aggregation type by default. And so I don't have to do a lot of work. I can just say create, and there's my folder, and there's my first two metrics already created for me. Let's now add some dimensionality. We're going to go back to our repository here. This is just a Git repository, and I've organized my semantic modeling objects in folders. So here's some dimensions I'm going to add to my model. I'll add a customer dimension, a date dimension, and a product dimension. So I've added that. There we go. Now, all I need to do to hook this up is to create what we call a relationship. So what does that mean? Well, we know that our customer key is going to relate to our customer dimension. And what I just did there, if you notice, is that I just created that relationship. Now, what happened? Look at all the data I got, or metadata I got with that single click. I got two different hierarchies. I can roll up my customers by geography zip code, as well as by city and state. Okay. And why did that happen? And it's actually organized nicely in a folder called customer attributes. Why did that happen? If I drill down on that customer dimension, what you'll notice is my breadcrumbs here show that the customer dimension is itself another model. And the customer dimension contains two other embedded models, including my geography dimension, which is another model. So what you're seeing here is models built within models, true inheritance, that you can see that by doing that, I can allow and create models really quickly, and I'm going to create those models consistently. So for a data steward, this is awesome. Let's go ahead and let's hook up my product. Now that you see I got my product hierarchy there. There you go. I can roll up product line, etc. And then let's do some dates. Dates are interesting because I got multiple dates here. I got order dates and shipping dates. Watch what happens. I'm going to create a relationship and create a role play relationship. I'm going to do it for order and I'm going to do it for ship. Just by creating that prefix, what I now have is I have a date folder. And you can see here, I have my order date hierarchy, and you can see that it inherits the structure here. So you can see I have a retail 445. I can do all kinds of things here when it comes to dimensions. When it comes to time, you can do amazing things to support your business. This happens to be a retail business, so retail 445 is obviously a good idea for a way of looking at your data in reporting periods. Okay, what else happened? What you notice is that in my source code control activity, these are the 4 files that just created. So I can go ahead and check those in and check those into Git. So I don't have to be know how to do GitHub, do command lines and crazy stuff. It's all done for you right here through the interface. I'm not going to check it in yet because what I want to do is I want to test it first. So let's deploy our Dale model here. So that's all I had to do is hit deploy. And then if I go to my view here, I can see there's my Dale model, and I have all my connection details for starting to explore the Dale model. Let's start with Excel. I'm just going to go ahead and connect to Excel and connect using my analysis services connector here. So I'm going to go ahead and paste in that URL that I just copied, which is a connection string back to the at-scale semantic layer. So there it is. It's going to use single sign-on, and I'm going to be able to go ahead and choose my catalog, and there's my Dale model, and I'll go ahead and click OK. Voila, I'm connected live to my Dale model. And there's all my metadata that I just created. There's my order quantity, and there's my 2 hierarchies. Remember my 2 hierarchies? Let's go ahead and look at it by geography, and let's do some drill down. So I'm running live Databricks queries right now. That's against the Databricks Lakehouse. So I can also turn these into cells rather than using pivot tables if I like. Now in Power BI works in a similar fashion. So I'll go ahead and connect Power BI, and I'll connect Power BI directly using the built-in analysis services connector. So this is unique to at-scale because what you're going to see here is I'm going to go ahead and connect directly in a live connect mode. So you can only do this with at-scale and Power BI Premium. Then this matters. Why does it matter? Because you can see here, there's my Dale model. I'm going to be able to connect and start working with this Dale model without having to understand where my tables are in my lakehouse. Because my data has already been modeled for me. And you'll notice it says live connection down here. And you notice that there's the same metadata I just saw in Excel. And I can go ahead, of course, and run my queries using my same organization that you saw there. And just like that, I'm now querying data and creating dashboards in Power BI without doing any data modeling. And I'm not only just creating dashboards, I can also use and create DAX expressions. So see this new measure? I can just click new measure. I can write a formula. Let's take orders times 2. That's dumb, but it's illustrative. You can see that new measure shows up here in my model. And just like that, I've now ran DAX connections or DAX expressions directly against Databricks. Can't do that with direct query mode. You'll notice if I go to the model tab that the reason why this all works is that Databricks has inherited the model that I just created from at-scale. No additional modeling needed. Okay, so let's go and let's look and see what happens in my Databricks workspace. So let's come back here. Let's go back to catalogs. Remember, we have our catalog here. So let's go ahead and let's just hit refresh here. And just like that, there you go. Dale now shows up. and Dale now shows up as a table in Unity Catalog. So I didn't have to do anything there. There it is. There's my model that I just created. So let's go to Genie. Let's create a new workspace. Let's call it the Dale workspace. I'll choose my warehouse. How am I going to do it? I'm going to add my table. I'm going to look for Dale. There it is. Added my Dale table. Added it to my workspace. Ready to ask a question. Let's ask a question. What are my sales by product? Let's see, and state. Let's do state. With a sales price over $1,000. So let's look at our expensive products here. So I didn't have to do anything here with the LLM or anything. I was able to create my semantic model. Genie now is going to take advantage of all those semantics and run a live query. And there we have it. And I can see that generated code there. Very simple query. I can also run that query in my Databricks editor. Let's go ahead and do that. And it's all integrated, right? So I'm running against my semantic model now. And now that scale isn't only delivering the correct answer every time, it's also speeding up the queries by using aggregates, building and using aggregates in the Databricks workspace. So it's really optimizing your lakehouse. And I can go ahead now and turn that into a dashboard simply by saying add to dashboard. I'll create a new dashboard. It's called Dale. You're going to be famous after this, Dale. Call it new query. And just like that, I've now created the beginnings of a new dashboard here. And I can go ahead and create a chart just by doing this. Create a chart like that. Put it there. Use the Databricks really cool AI to let it generate my top sales products. So there you have it. Really cool, right? Very easy to do and very easy to build a model. Well, you saw that I built that model and I built that model by hand. What I didn't show you is that what I could have done is I could have generated a model straight from scratch. So if I hit generate model here, there's the model I just built by hand, but there it is, all generated with AI. You can see it reused all my measures, all my dimensions. So we can do a one-click model build. So that was a lot that I showed you. I really hope you got a good idea for how a semantic layer can sit on top of the lakehouse and make it smarter and make it work across a variety of different consumption styles. So thanks a lot for listening. Back to you.
Thank you, Dave. That brings us to the end of the webinar today. Thank you for joining us, and we hope to see you at a Databricks or at-scale event soon. Thank you.